Hi guys. Hey, just going to get started here on chapter 9 on agriculture. Really hits home for where we're at, and I think the concepts that it talks about, including all the things that go on here in the Midwest, really has a major play or impact in in the future, and really how much we can do locally to make a huge difference environmentally. So we'll go ahead and get started here. And I'm going to try and highlight some things. Um, Hold on. Share screen. There we go. So I'm going to try and highlight some things, and we'll kind of go from there. So what we're talking about is soil and agriculture, and the role that our soil plays and the role agriculture plays globally in environmental issues. So what we'll talk about today is the relationship between soils and agriculture, the different agricultural developments, pretty much the fundamentals of soil science, and then when we look at causes and consequences, why is our soil going away? What is going on? And how is it being broken down? And then if we look at that, then we can talk about principles of how to save or protect our resources that we have. So I'm going to try this here. So highlighter. I don't think that worked. No. So what we're going to talk about is highlighter. Hold on. Sorry. All right. Now we got a highlighter. So basically, if you look at what we have in the world, our world of agriculture consists of about 38% of the Earth's surface. And if we talk about agriculture, what we're talking about is crops, livestock. The ground that we have predominantly around here is cropland. And so cropland is, the ground that we plant the crops in. Rangeland or pasture land is we predominantly see with livestock. And let me find livestock. Oh, I'm making a mess. So, we do have some livestock with rangeland, pasture land, mainly used for cattle. We do have some confinement systems, which I don't really talk about here, for hogs, swine confinement systems. Soil is really such a huge topic, and it's so complex, and we take it for granted. It's everything that's our ground is, and it's made up of abiotic and biotic factors. Rocks, soil is made up of bits and pieces of our broken up bedrock and our water and our air, macronutrients, micronutrients, all the things that really are essential, including the little creepy crawly critters and the big critters, and so we see such a huge interaction in our soil. 100% it's renewable, but we can make it to where it is not, so we can destroy it very easily. So if you think about our human population, pretty much, and I'll say this again down the line, 7 major crops feed the world. And with our population increasing the way it is, we have to find ways to sustainably get enough production of food to suit the number of individuals that we have on this planet. Now, with that said, we produce enough food to feed the world 4 or 5 times over. And so you have to ask yourself, where are some areas that we can make improvement? And there's a couple of really neat places in food waste. I know that several of our students are working on that and efficiency of that, but also in the efficiency of the production of the soil or the food itself. And so efficiency of food, I'm making a mess when it comes to production. Now, here's the deal. If we don't do it right, we can destroy our soil. And so whether it's being blown away or washed away, definitely an issue. If we are not creating a system that keeps roots where they need to be, roots are so vital. When you hear us talk about planting, we talk about roots and shoots, and roots are vital to keeping our soil where it's at. We are constantly losing air, soil, whether it's due to degradation or it being washed away. So, is it still healthy, nutrient-rich soil, or is it broken down into really? It's interesting. Color is a really cool indicator of soil, and what I mean by that is soil that's black and dark. That's really nutrient-rich soil. Soil that's maybe white or gray or tan, not so much. And so it's kind of interesting where we have areas on this map that kind of just stand out. And we have caused land to become non-arable, or in other words, no longer able to be farmed as a result of our destruction of that soil. So kind of neat. The green here is stable. There is stable land there, but if you look at kind of the areas that are green, pretty much population wise, there's not a lot there. I mean, if you think about up in the upper reaches of Canada or upper Russia, same thing. And so where do we see the breakdown of soil or the degradation of soil really taking place? And we see a lot of it in deforestation and overgrazing, but we also see 28% in our agricultural methods. And so for the most part, it's not that we're building factories on the ground. It's pretty much that we are causing, by overproduction, deforestation, overgrazing, we are causing the breakdown of that area. And so if you think about when agriculture really came about, about 10,000 years ago, we start to see agricultural methods start to take place. And what I think is pretty interesting is when we look at like areas down here in the Andes with the potatoes. A lot of people think that potatoes are from Ireland, and really there's over 200 varieties of potato, maybe more, and most people don't know that it really came from South America. Same with corn. Corn came from the Yucatan Peninsula in Mexico, and all these things were basically selected for. We talk about artificial selection. People chose things that they could eat and that were good and they were easy to farm. And lo and behold, they just kind of went from there. And so we saw this changing of our going from a hunting and gathering society to an agriculture-based society. Now, again, pretty mainly it was for trying to protect a population of people And so they came together and started these different agricultural communities. And so as a result of it, we see a lot of the crops that we have today. And so when we talk about traditional agriculture, right? So either we're using human or muscle power or animal power. And so basically we go from hunting and gathering to beast of burden type stuff. Um, you know, basically the stories of putting two fish for every kernel of corn, growing type stuff. And then we switch over to a system of subsistence farming or subsistence agriculture, and this is where people are producing enough for themselves to sustain their family. But then all of a sudden we get into a scenario where, and again, this is when about 4,000 years ago, somewhere in there, where we start to see people producing excess amounts of food so they can um, so they can sell it, so they can trade it. 1 minute while I get my power cord. All right, I'm back. Sorry about that. So now we got power. So we see this changeover taking place, and um, then it becomes a system of goods and services. So we don't yet have fossil fuels taking place, but eventually we do, and we see fossil fuels starting in the Industrial Revolution, um, and essentially, so it's like with my grandparents. My grandfather had a farm in Weston. Started out with horse and plow. This was back in the early 20s. They didn't have. He came here from Germany in the 1920s and uh, bought a piece of property in Weston and started farming. And I remember him telling me about they had a team of horses and they would plow the fields. And eventually, in the late 30s, um, they were able to switch over to chain-driven equipment, and so they would stack a chain in the field, and the machinery would be pulled along this chain, and that's how they did their agriculture. It was a chain driven equipment. Basically, it would be pulled along this chain, and then eventually gas powered equipment, and then eventually diesel powered equipment. And so it's kind of funny. My grandfather went through this time period all the way from, and he's long past, but from horse driven machinery to the Industrial Revolution. Industrialized agriculture, obviously, we're using um, equipment, big equipment, to yield massive amounts. And I guess really what it comes down to is so first of all, I said earlier that 7 crops feed the world. Well, if you think about it, the reason why these 7 crops really majorly feed the world, something like that, it may be 8, but corn, beans, sorghum, wheat, things like that, potatoes. The reason why they feed the world is because they're easy to plant and harvest, and they do well in straight rows. right? So when you think about what we are, we're a monoculture. There's not a lot of diversity in that. And so um, somewhere in the 70s, it would be like 77 or something like that, we see the advent of what's called the Green Revolution. And the Green Revolution is nothing to do with really environmental, but what it is using technology to maximize our yield and production. That technology, whether it be tractors, whether it be fertilizers, whether it be different types of farming practices. I think a guy by the name of Francis Childs produces somewhere in the neighborhood of 400 bushel per acre, or did. I don't even know if he's still alive, but this is maximizing where we're at. And I would contend that as we're looking at this stuff, there's a lot of ways that technology will allow us to really do great things for our environment and still increase our yield. And so there's a lot of discussion and a lot of area to play with that. If you look at our soil itself, I talked about this already a little bit. All the microscopic, the macroscopic organisms. There's now a push for worms. Don't forget the worms, right? Earthworms do such a great job of turning over soil. And if you think about all the organisms that are in there, all of them play a role in our healthy soil and help us break down the material that's in there. And so they really break down the abiotic and the biotic material and create this living system, this soil that's alive. Our parent material, I think I talked about that for a minute. Our bedrock here in Livingston County, that's limestone. And in other places, the reason why the soil looks the way they do is they have bedrock that's of different material. And so, like, it's kind of interesting. On beaches in Hawaii, a lot of the beaches are made out of volcanic material. So pumice and basaltic lava and mafic, all those different types of material, that's their bedrock. And so how does it break down? Well, we can break down a number of ways. We can break down through physical or chemical means. So physical, wedging, organisms, animals burrowing and exposing stuff. Chemical, that could be the plant acids around roots, or acid rain, or anything like that. And so we see this chemical, physical, and biologic all taking place together. And so we see this breakdown that we call weathering, setting up our parent material to become our soil, our dirt. And again, if you look at what it's about surface area, smaller particle size. Erosion, not too hard to understand that. Erosion is again the breaking down or moving of that material from one place to another. And if we have a root system that's solidly intact, it really does make a huge impact. Now, organisms can cause that to have a problem. And as a result, play a major role. When we talk about humus and humus, humus is what you put on a chip. This is not that. Humus is what is on top of our topsoil. It's what our topsoil is made out of. And what it is dead decaying matter. And so it mixes in with our parent material, or our bedrock that's been broken down, and we create soil. And so if we look at a soil profile here, starting with the O horizon, which stands for organic, you have organic material that breaks down. And then as we go down, the A horizon, which is our topsoil, it leaches down through our different horizons. And you'll note it used to be that it was just the A, B, and C horizon and D horizon, which A horizon was topsoil, B horizon was the topsoil leached down, C horizon was the broken bedrock. But what we now know is that there are so many different components to these horizons. And so we now have 6 categories that kind of make it up. And as a result of that, we're able to characterize what we have. And so when we're looking at soil, I think I mentioned it earlier, soil color is a pretty big thing. And what's cool about that is the darker it is, the the better the soil is. Texture, depending on the size, we see that you can have three basic types: clay, silt, and sand. Those are the soil. Those are the texture sizes, and very rarely do we have it just one. I mean, mostly it's a combination. And so, in order to come up with this combination, if we have equal parts of every one, we refer to it as loam. And this chart right here basically allows us to figure out, okay, what is your soil type? And so if you have, let's say, soil that is 40% silt, 50% clay, and 50% sand, it's leaning towards a clay type material. And so you can lay it out as to where or what your soil type is. And so really good for agriculture. We use that quite a bit, especially for the type of soil that we have in different places. Soil structure, is it clumpy? Does it allow us to plant into it? We have what's called compaction. Compaction that takes place whether it's through machinery or through repeated rolling over the material or over the dirt. And so this plow pan is when we see that our roots can't get through because it's just too freaking hard, right? pH of soil, we constantly see fields being adjusted for pH. And if it's too basic, it kills plants. If it's too acidic, it kills plants. And so we have to have this perfect pH to match the crop that we're growing. When we talk about the exchange of cations, in other words, our nutrients that are involved, you know, whether it be calcium, magnesium, or potassium, or whatever, we have to be able to get nutrients into the plant, and it's vital in that part of a plant's life. And so we see that, you know, it creates fertile soil, and fertile soil allows you to grow plants. There's obviously differences in agriculture and soil around the world. Sweden agriculture, basically they come in and they farm a plot for a couple of years in a forest, and then they let it regrow. What we found is that the same with us. We're different in the sense that we have crop rotation that takes place. We go from corn to beans to corn to beans, sometimes other crops as well. But every region has its different types of soil and differences in agriculture as well. Deposition. So when you think about soil and material, basically what happens is you either lose soil or you gain soil or it stays the same, just something like that. And so our goal is to keep soil where it's at. If it erodes, it usually is blown away or goes down the river or goes into a lake or a body of water of some sort. And so deposition means it's coming from somewhere else. What happens is if we look at like lands along the Illinois River, the Vermilion River, over on the opposite side of Chautauqua Park, this is a floodplain system. And so excellent for farming, but the problem is they get water. And so a lot of times we see erosion taking place. Another way that erosion causes problems is through excessive tilling, overgrazing, that type of thing. I don't have any pictures, or I'd show you some. But if you think about where we're at, roughly looking at our topsoil, I think I last saw a graphic, and maybe I showed it to you, that our topsoil of our area really is lost about, and I'm using the inches, but about 3 to 4 inches of topsoil since people started farming. And it's interesting, you go, where did it go? Well, probably most of it went down the river or was blown away. And so really terrible farming practices back in the 20s and 30s. We've improved so much. When we talk about erosion, plants and their soils and their roots protect our soil from erosion. And so if we remove them, cause a problem. Every drop of water is mechanical action. As it drops on the ground, it creates some sort of mechanical erosion or mechanical breakdown of the soil. And so if you look at where we are at, there's a big push to really try and conserve our soil through erosionary methods. And that's really where the soil and water conservation districts of the United States came about. And that was from the Dust Bowl in the 20s and 30s. And so if you look at this diagram right here, this is a drop of water, right? You don't think much of it, but it does do some mechanical breakdown of soil. And so if we talk about an entire area come out, it's called sheet erosion. This is real. It's where you see this area breaking down and it starts to set up for what we call gullying. And gullying is a big ditch and that soil is all gone from there. We are the number one cause, just what it is. We cause erosion to take place at an unbelievable rate. That's not just here, that's everywhere. And so if we work on agricultural methods, which is huge, and we're never going to get, we have to have agriculture. Agriculture is really what allows us to survive, and God bless our farmers and our stewards of our land. If you think about it, I'll reuse the term steward and farmer interchangeably because that's what they're doing. They want to make sure that our world and our farm and our ground is protected, right? And so if we look at over farming or overproduction or degradation of soil, desertification takes place if we overuse it, whether we cause it to be salty through salinization or break down these different areas because of bad farming practices. So if we have overgrazing taking place, if we're not setting up our soil by keeping our root structure together, really does cause a breakdown of the soil. What's the impact? What's the cost? Well, we lose so much area as a result of improper farming techniques and overproduction, overgrazing, degradation of the soil. And so what's this look like? Translated into dollars and cents, billions and billions of dollars. And what we see is a lot of groups working with these third world countries to really prevent that from happening and teaching new techniques to areas that they didn't have them. And so we learned a lot from the Dust Bowl. The Dust Bowl, really, there was a lot that went with this. And it wasn't just improper farming techniques, but that had a lot to play with it. It was also coupled with the worst droughts that anybody has ever seen. And so what takes place is this picture up here, this is called a haboob. Haboob is, this is when the wind pushes down on the soil and picks it up into the air and it creates this black blizzard. And I would have showed you the video on the Dust Bowl. If you get a chance, watch Ken Burns' Dust Bowl. Pretty powerful. So we see Soil and Water Conservation Service come about. And again, what were they trying to do? Work with landowners to make sure that we had proper stewardship techniques taking place. And this is a federal organization. If you look at the Natural Resource Conservation Service, basically we're bringing everything together. This is our Soil and Conservation District. Is basically what it is. So again, it's global. It's trying to protect our resources, soil, water, and air. What are some practices that we do? You guys are all familiar with this: crop rotation. This is what happens around here. We see contour farming. A lot of that over in the Sonneman Cougie area, just because that's where the glacial moraine kind of took off or stopped, I should say. And so we see a lot of that type of farming techniques taking place. Terracing, there are some terraces over there as well. Intercropping, we see this in areas where maybe we have some problem really bad with wind. Not a lot of that around here. More of a third world country type situation. Windbreaks. Unfortunately, we used to see a lot of windbreaks here. We need to see more of that, I think. Really good windrows, hedgerows, really did protect our soil from being blown away. People are just not doing that as much, and it's unfortunate. No-till. No-till basically means that they are not turning over the soil and then planting. You know, it's really powerful, but it also saves resources. Not as much fuel input costs as a result of that. Pros and cons, you know, where do we see no-till? Us, right? And so it's a great way to really protect our soil. A negative is increased use of herbicides and fertilizers. But here's the deal. Our neighbor puts manure, pig manure, on all their farms, and they're able to utilize that material that's being produced from their swine confinement situation. Again, plant cover. You want to look up a really cool dude, a good friend of mine, Chad Pergracki. We were going to Skype with him, but they are planting 1 million trees in Illinois to reduce erosion. He also goes with barges and picks up the Illinois, Mississippi, Kentucky, Tennessee, and Missouri rivers and Ohio River from garbage. It's a pretty cool deal. You should look up Living Lands and Water. Irrigation, don't have a lot of that around here. There is some over by Fairbury, and basically that's pulling water out of our aquifer to spray our crops. Now, the problem is 80% of the water that's sprayed on crops evaporates. So basically, you're depleting your water supply. With that, salinization, or the buildup of salts, takes place. And so it can cause a real bad problem. These crop circles right here, these are out in Kansas probably. Basically what happens is called center pole pivot irrigation. And what happens is the pivot arm comes from a well that's drilled right in the middle of that thing, and it goes all the way around. And so if you fly over the top, it looks like crop circles, and that's a center pole pivot. Drip irrigation systems more efficient, harder to manage. It only drops a little drip to each plant. but it's pretty intense, right? If we look at fertilizers, the more fertilizer you put on an area isn't always the better. You can also burn it out, and so there's this balance of the correct nutrients. Organic fertilizers, that's the waste. We actually used to have um, our waste that came from our wastewater treatment plant. So human poo and pee used to get squeezed down and put on fields. Now it goes out to the landfill, but could be used for that. Organic fertilizers, pretty much now manure from horses, cows, pigs, etc. Um, Inorganic is stuff that we've produced. If we look at application of fertilizer, I remember my grandpa when I was a kid in 1977 coming home and putting his fist on the table and yelling, "This is the greatest." We had 77 bushel corn. And now, because of the Industrial Revolution, we've seen a real awesome thing. Not industrial, agricultural revolution, the Green Revolution. Um, it's nothing to see our corn being 260 bushel per acre. A bushel basket's about, take your arms and fill it that full, and that's what a bushel basket's kind of like. But again, over application of fertilizer does have its limits, and it can cause a lot of problems with our water. So aquatic plants are no different. They use nitrogen. And so what happens is you have what's called artificial eutrophication, where the soil leaches the water through runoff, or leaches the nitrogen through runoff, and it feeds aquatic plants. And then you get this algal bloom that eventually dies, takes all the oxygen out of the water, and it kills everything. So it can be a problem too. So this would be kind of an example of artificial eutrophication. Again, fertilizer runs off and creates an algal bloom. Algal bloom then causes a problem and kills everything, and then the fish die. Overgrazing, same thing. It can remove too much of the grass, the plants, causes erosion to take place, cause it to where you cannot farm there anymore. And so there's a lot of protection to our rangelands and our crops from overgrazing. People are very careful of this. I think this is pretty interesting. Over here, because this fence is right here, this area has been protected. Over here, not protected. So you had some sort of either cattle or sheep or goats or whatever graze this part. This is a healthy ungrazed plot. This is not so much. And so as a result, this is a pretty much non-productive plot of land. Clear cutting, whether it be trees in the logging industry, it does cause amazing erosion to take place. And it takes a long time for it to all grow back. And so it can get to a point of no return unless somebody steps in. Food Security Act of 1985, basically what we're looking at is we are seeing soil and conservation taken to be as serious as it can. In other words, basically they're protecting and adopting a plan that supports what we have. Conservation Reserve Program, or CRP. You'll hear us talk about this. I know the boys who are working on the pollinator plots talked about this quite a bit. Basically, it's protecting land, but getting a price for your ground. So you get a guaranteed price not to farm it. Freedom to Farm Act, again, basically it creates this program that promotes good conservation practices. It's trying to really make an impact. And equally the same low input sustainable agriculture program. They're trying to create a sustainable agriculture practice. And again, it provides funding for them. Farm-centered agricultural resource management program. Basically, this is causing us to really educate and encourage communities to proper conservation methods and conserving our soil when it comes to agriculture. And pretty much this is more of a global program. It's not a really a United States program. It doesn't really affect us that much. So conclusion, right? So if we kind of work on some things technology-wise, we really could create some amazing programs that protect not only our soil, but our water. And I think people are doing that. And furthermore, if you look at where we're at when it comes to agricultural production, there is a shift in the technology to get better yield or maximize our yields per acre and really focus on the ecology or the stewardship of our ground. So I appreciate all you guys paying attention. I miss you guys. I hope everything is well. And stay safe.